In number 21 here in 3.8, we're taking the sine of the sum of x and y, and that's equal to x plus cosine of y. So we've got some trig involved right here, but the good news is, you guys, I don't see any products or quotients right here that are going to require the product or quotient rule. So hopefully this one isn't going to be too bad. I don't think there's any manipulation we need to do at the beginning, so let's get working on it. Our left side is just sine of an angle, and the derivative of sine of any angle is cosine of the same angle. That is really important, guys. The angle never changes. Cosine of the same angle, but wait a minute now, times the derivative of the angle itself. So now we need to use the chain rule right here and take the derivative of the sum of x plus y. Well, the derivative of x is just going to be 1 plus the derivative of y is dy dx. So that's what I've got here for my derivative on the left side. It's important that everybody understands that the cosine of x plus y is one big factor right here that gets multiplied by this. Without those brackets I just drew, it might have looked like maybe you were supposed to multiply these things together first, and that would be incorrect. We got to take the cosine, ooh, now I lost it. The cosine of the x plus y, which I blew it right here. Here we go. So that was a 1 plus a dy dx. Okay, and remember that that cosine there of x plus y happens first. Okay, that's your left side. Right side should be easier. It's just a sum, so we just go term by term. The derivative of x is 1, and then the derivative of cosine of any angle is the opposite of sine of the same angle. So that derivative of plus cosine of y is now going to be minus sine of the same angle, y, but then multiplied by the derivative of that angle, which is going to be a dy dx. And since the x and the cosine y were being added separately right here, really there should be brackets right there, you guys. That 1 is a secondary thing that was taking place there. Okay, so this gets kind of interesting now, and as I recall, yep, I remember why people asked this question in the past. This left side is tricky. What we need to do, guys, is get this thing in expanded form and then isolate the dy dx all by itself, usually by factoring and then dividing, very similar to what we did in problem 15 and problem 11, if you worked on those ones yet. What makes this one hard to do is that left-hand side. And without the brackets that I drew, where right here and right here, it can be difficult to see what's going on. But this, you guys, is one big monomial expression. It's being multiplied now by a binomial, so this cosine of x plus y is going to need to get distributed into that binomial right here. That really doesn't seem natural, but yeah, that's what has to happen. So cosine of x plus y times 1 is obviously just going to be cosine of x plus y. And then we're going to add to that now the cosine of x plus y multiplied by dy dx. I'm going to put the dy dx in front of that. I think it'll be a little bit easier to understand, times the cosine of x plus y equals, and on the right side, I suppose those brackets really weren't necessary, 1 minus, and I tell you what, I'm going to do the same thing. I'm going to put the dy dx first now, and then multiply that by the sine of y. So what is hopefully now easier to see is that we have 1, 2, 3, and 4 terms in this entire equation, 2 of which contain the dy dx that we need. So I'm going to get those two together on the left-hand side. So a dy dx multiplied by the cosine of x plus y, and then this term, which was negative on the right, is now going to turn positive when we bring it to the left. So a plus dy dx multiplied by the sine of y. All of that equals, I'll start with the 1 that was already on the right, and then this term, which was positive on the left, now becomes minus on the right. So minus cosine of x plus y. And again, I'm going to do this in one step, guys. I'm going to factor out the dy dx and then divide by the binomial that's left over. So I think this should be our final answer now. Dy dx is equal to, here we go, the numerator is the former right side of the equation, 1 minus the cosine of the sum of x and y. And the denominator is what's left when we divided out the dy dx, so that is going to be a cosine of x plus y, and then a plus sine of y down there on the bottom. And that's kind of a mess, you guys, but I certainly don't think that anything right here is going to be able to be canceled out. We are absolutely not going to distribute a cosine here and here, because you only distribute numbers, guys. Constants or variables, cosine is an operation. So we are certainly not going to do that, and I don't see anything else that cancels the way it is. So that's what I've got here for my answer for problem 21. Quick glance at the solutions manual for those who are concerned, and it looks like they've got theirs, yep, in the exact same format that we have right here. So okay, there's number 21.